Hello students, today we are going to discuss Unit 1 Introduction to Software Engineering. It has three subtopics: what is software, what are software characteristics, and what is software engineering, the definition. So let's see what is software. Software is three parts, we can say: instructions, data structure, and documents. Instructions are nothing but our computer programs. Data structures are the data or the information on which the program manipulates. And the third one, that is a document, are used to describe the operations and the use of the programs. Let's see the characteristics of software. Software has three characteristics. First one, software is developed or engineered. It is not manufactured in the classical sense. Second, software does not wear out. And third, although the industry is moving towards component based assembly, most software continues to be custom built. So let's see each of these characteristics in detail. First one, that is software is developed or engineered. It is not manufactured in the classical sense. Although the hardware and software are being manufactured, there are certain similarities, but still there are many fundamental differences. Both the cases, high design help you to achieve high quality, but in case of hardware, there comes a manufacturing phase that is not there in case of software phase. Both the activities require the construction of a product, but both the approaches are different. So the software projects cannot be managed in the same way as that of the hardware projects. So the total steps or the steps to develop a software is totally different than that of hardware. That's why we say that a software is being developed or engineered and not manufactured in the regular way that we used to. The second characteristic is software does not wear out. See, in this figure, you can see the failure rate on the y-axis and time on the x-axis. In the initial stages of a hardware, there is a high failure rate. As the time passes on, these failures are being removed, maybe the manufacturing defects are removed, and this failure rate drops down and moves into a steady state that is very low, and it goes on for a longer period of time. And after some time of period, the hardware component suffers effects from dust, vibration, temperature extremes, and so on, and becomes to wear out. And there the graph goes up. So we can see here a bathtub curve. This relationship is often called as bathtub curve, and it indicates the life period of an hardware and the failure rate during its lifespan. Whereas in the case of the software, you can see in the figure there is not a bathtub curve. So in the initial stages of the software, there is a high failure rate. These failures are being corrected, and you will see the darker line. This is an idealized curve. The idealized curve is the simplification of the actual failure model. So what is the actual failure model? You can see the thin line in the graph. That is the actual failure model of the software. In the initial stages, there are lots of errors, and these errors are corrected as the time goes on. But all of a sudden, there is a need for change, maybe due to the requirement change or maybe due to maintenance. And as soon as this change happens, and there comes up new defects, and suddenly the graph or the curve spikes up high, and that leads to an increased failure rate, and this is due to the side effects of those change. And again we correct those errors, and the failure rate graph goes down, but again there is again a need to change, and again there is a spike up high, and this failure rate spikes high, and we make the changes, we solve the errors and bring it down again. But now you can see that one after the other change leads to a higher failure rate as the graph goes on, and the actual curves goes up and up. So when a hardware component wears out, we can say that we are having a spare parts, but in case of software there is no spare parts. Every software error or every software failure indicates there is an error in the design or in the process. So we say that software maintenance involves more efforts than that of hardware, and it has lots of complexities than in the case of hardware maintenance, because in hardware the components are already ready and you just need to make those changes. Let's see the third characteristics of software. Although the industry is moving towards component based assembly, most software continues to be custom built. In case of hardware, as I told, that there are lots of components and you just need to assemble the components. But in case of software, it is custom built. Each software is built from the very scratch. Now, nowadays, software also still continues to be custom built, but has come up with certain changes that it has started building smaller components which can be assembled into a bigger software, but it is not done on a very broad scale. So software components now need to be designed and implemented so that it can be reused in many different programs, but it has just started and still the software continues to be custom built. So we need to develop reusable components which have both the data and the processing that can be applied on those data, so that those software engineers can create new applications based on those reusable components, and they can also focus on those areas where the truly innovations or changes are required in the designing. Next one is the definition of software engineering. So engineering, we all know that it is the use of scientific principles to design and build the product. Now, IEEE defines software is a collection of computer programs, procedures, rules, and associated documentation and data. We have already seen the definition of software. So, software has three important things, that is the computer program, that is the instructions, the procedures, and the documentation, as well as the data, that is the data structure. Now, IEEE defines software engineering as software engineering is a systematic approach to the development, operation, maintenance, and retirement of the software. So, here we are applying the engineering rules, that is, the scientific principles to design and build the product. And what is the product that we are building? It is the software. So, it helps in the development of the software, in the operation of the software, in the maintenance of the software. Boeing defines software engineering as software engineering is the application of science and mathematics by which the capabilities of computer equipments are made useful to man via computer programs, procedures, and associated documentation. So here Boeing considers that software engineering is scientific principles or mathematics. By using those scientific principles, we are using the computer hardware and it is made useful to men, but computer hardware cannot be used directly. For that we need the software. And what is software? It is again the programs, the data structure, and its associated documentation. Again, let's see the definition given by Fritz Bohr. He is a German computer scientist. He defines software engineering as software engineering is the establishment and the use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. So here software engineering, again, it is the use of the engineering principles to develop the software that is cost effective and that on which you can rely upon, and it works efficiently on the real machines. Real machines nothing but our systems, our computers, on which we can work and which we can depend upon. Thank you.